Okay, section 10.4, point slope form. Let's kind of go over a review of some basically formulas of what we've learned. So let's look here. We know standard form, okay, which is ax plus by equals c, which don't confuse, this is just a constant. These are your variables, and it's going to come out to some constant. Okay, then we learned slope intercept form. Okay, and that is y equals mx plus b, this being your y intercept, this being your slope. Okay, and let's not forget that slope is basically m, which is your slope, which equals y2 minus y1 over x2 minus x1. That gives us the slant, okay, between 2 points on a coordinate plane. So now we are on to point slope form, okay, which looks like this. It is y minus y1 equals m, okay, x minus x1. Okay, let's not forget, we do notice something in here. That is still our slope. Okay, and now it's just giving us a point. Okay, very easily to see where this comes from, if you really want to think about it, is if you have y2 minus y1, x2 minus x1, that all equals m. Well, I can come in here and subtract x2 minus x1 on this side and do the same over here. Okay, this reduces this down, and therefore you end up having y minus y1 equals m x minus x1. Kind of an easy way to kind of remember it. Sometimes this helped me in the past. If this doesn't help, don't stress it. I'm going to show you how we kind of get to all these. Go through this kind of quick today. We'll do more in Hawks. Okay, so let's do one real quick. Just kind of see how this works out and why it's useful. So let's graph the line. Graph the line with the slope m equals negative 3, 4, and which passes through the point 2, 5. But it gives us everything. We don't have to do really any figuring. Let's just kind of remember. We know what this is. We know this is an x and this is a y coordinate. Okay, so our slope m is equal to y2 minus y1 all over x2 minus x1, which already figured out is negative 3 over 4. So that's our slope, which is also our rise over run. Oops. Not rise over rum. Wrong class. Okay, rise over run. But notice we have a negative on the outside here. In fact, I'm going to make that a little bit more intentional on the outside here. Be a little bit more careful with my drawing. That is actually going to equate to either this, and I'll show this to you graphically here in just a second. But that's going to equal negative 3 over 4, which is actually going to be basically a fall or go down and then a run. But you could also do it as a 3 over negative 4. It works either way, okay? Like I said, I'll show it to you graphically. And then, of course, we have our coordinate points, which are 2, 5. So let's graph this. I'll make a little rudimentary graph here. So let's see if I can draw this as good as possible. Maybe I should have thought about this and maybe put in a graph, but still. So I've got a graph. And let's go 1, 2, 3, 4, 5, 6. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have our y coordinate. We have our x coordinate. Let's grab a different color here. Okay, let's first find the point 2, 5. Well, we know that's going to be 1, 2, sorry. Let's see here, get that off. 1, 2, we're going to go over 2, because we always go x first, and then go up 5. So we'll 1, 2, then 1, 2, 3, 4, 5. There we are. There's our first point. Now, as stated, I'm going to go with this one first, okay? So, to see our slope, we already see the slope, and that is down 3 over 4. So, let's go down 3. 1, 2, 3. And then let's go over 4. 1, 2, 3, 4. There's our new slope, okay? This is the slope of this line. So if I can draw this, which you can see, it is a negative slope. Okay. Let's come back here. Notice from here to here, we went down 3, but from here to here, positive 4. Just like what I showed right here. Well, if we decide to use this one, this is going to be a rise, okay? But then it's going to be a run in the opposite direction. So let's do it opposite. Let's go up 3. 1, 2, 3. And then let's go run the opposite way. 1, 2, 3, 4. We end up in the same spot. Whereas here, we have a positive 3. And here, we have a negative 4. So you can see it works either way. And you can also check yourself. You can come in here, just kind of change everything back. Notice that this point here is going to be point 2, 5. Well, what's our new point? Well, 1, 2, 3, 4, 5, 6. Okay, 6. 1, 2. 6, 2. So if you have x1, y1, x2, y2, all of that is going to equal, well, let's do our points. Let's do 2 minus 5, 6 minus 2. That's going to give us the negative 3 over 4. So you can see it works out. That is our slope. All right, let's continue on. Alrighty. This one right here, I'm going to just show you, and then I'm going to go into a little bit more depth here very, very shortly. So, once again, they give us the slope. We have an x and y value. Okay, so coming down here, the solution being, here is our slope intercept. Here is our point slope form. This is our formula. We took the points up above, which our slope is m equals negative 1/2. Our coordinate point is 2, 3. Okay, you're going to put in, you've got your x1, you've got your y1. Just put those into their appropriate spots. I do believe it was a 2, 3, yes. Okay, so the 2 goes in the x spot, the 3 goes in there, then you're just solving, okay? Notice right here, to get to slope intercept form, okay, what they're doing is they're coming here to get from here to here, they're distributing this into there. Notice that when you do that, you get 1/2 x, negative 1/2 x. Well, whenever you do 2 times multiplied, negative 2 multiplied by negative 1/2, you're going to get a positive. Okay? Then right here, they're solving for y. Okay? To do that, they're just adding 3 here and then adding 3 here. Okay? They're solving for y. Okay? Then you get to here. Now you're at slope intercept form, the thing we learned in the last chapter. Well, to get to standard form, now they're just getting all the variables on the left-hand side. Okay, so to do that, they're going to come in here, and let me just kind of switch to something lighter here. Come in here and multiply everything by 2. We cannot see that very well on that. Multiply everything by 2. Okay, therefore that's how you get the 8. then you're going to be left with the negative x, and then you're going to have 2y. Well, then right here, they're just going to add x and then x plus. Okay, that's how we're getting to standard form. Like I said, you're going to see it a little bit better shortly. Okay. So moving on down here, let's do the whole thing. We'll hit this up in just 1 second. I'm going to just show you this. Let's do this whole process here. Let's do it from scratch. So, we have coordinate points, but notice what they don't give us right now. Okay? No slope. So, take a deep breath, and let's just be intentional and know what we got to find. First, we got to find the slope. Well, we have an x1, we have a y1, we have an x2, we have a y2. Let's put it into our equation. M is going to equal, well, my y2 is a negative 2. My y1, I have to subtract it, minus 2. All over my x2, which is 4, minus a negative 1. Stick with the formula. Remember that. When you do the math on this, you're going to end up getting negative 4/5. Now we have our slope. Now, don't get confused. You can choose either one of these points. It does not matter which one you use. I'm not going to work them both out. If you want to do this afterwards, you're going to see you're going to end up getting the same thing in the end. It doesn't matter. So I'm going to use this one right here. Now I'm just going to plug it in. I've got x1, y1. So let's plug that into our equation, which is y minus y1 equals m x minus x1. Okay, I don't know why I'm sticking with red, but we'll go ahead and stick with it. So I'm going to be using the negative 1/2. So this is going to be y minus, there's my y, equals, well, what's my slope? Negative 4/5. All, then you're going to put x minus, that's a negative 1. Keep the negative 1. We're almost there. Okay. We got y minus 2 equals, distribute this to the inside. Remember, right here, a negative times a negative, this will all just become positive right here. Okay, so we have negative 4/5 x plus, minus 4/5. We are now right here in point slope form. Let's keep it going. Now, let's do what we did earlier on the other one, and let's try to get it into slope-intercept form. That means we need to get the y by itself. Okay? So, to do that, I'm doing everything opposite today, I guess, obviously. I'm going to take this negative 2, and I'm going to add it to itself here, do the inverse, and then I'm going to add it to the other side. That is going to leave me with y equals negative 4/5 x. Okay, right here I have minus 4/5, but let's remember, I don't have a common denominator here. This is basically over 1. So to make these the same, I'm going to multiply both of these, the numerator and the denominator, by 5. So 5 times 1, okay, is going to be 5. And then 5 times 2 is going to be 10. Then whenever you take negative 4/5 and add 10/5, you're going to get y equals negative 4/5 x plus 6/5. This right here is now slope intercept form. Okay, let's keep going. 1 second here, move this down just a little bit. Almost there. Because we're going to get this thing all the way to standard so you can kind of see how it all works together. Because it will be very useful to see this. Trust me. Well, to get this into slope intercept form, I now need to get x to the left side. Okay? So, doing that, I'm going to multiply everything by 5 because I want to get rid of those. So, to do that, multiply everything by 5. That is going to give me 5y equals negative 4x plus 6. Now I need to move the x to the other side, which means I need to reduce it off on one side. To do that, I'm going to add 4x here, then I'm going to take that 4x, I'm going to add it to the other side. Now we have 4x plus 5y, because that reduces off, equals 6. And this right here is your standard form. Okay, last little thing here. Parallel lines are lines that never intersect. So basically they have the same slope. Perpendicular lines have the negative reciprocals. Basically, if you have a slope, get this back into black. If you have a slope of 3/4, okay, if you have something that's parallel, they're going to be exactly the same. Okay, but perpendicular, okay, it would end up being negative 4/3. Okay, so parallel, same slope. I'll show you here on Desmos here. Notice that I'm using 2/3 for a slope here. Well, I have one equation, 2/3 x plus 1. This is this one here. 2/3 x plus 2, same slope. Notice they're parallel to each other. Okay, let's turn one of them off here. And this one right here, if you'll notice, it has a negative 3/2. It's negative reciprocal. You know, it's parallel. It's shooting straight up. So, kind of graphically show you how that works. Okay. Moving on, we will go ahead and get started back on some Hawks certifies.